All right, today we're going to talk about tangent lines. And the word tangent we've seen in the past as a function of trigonometry, where it was a ratio of opposite over adjacent sides in a right triangle with a given angle. Tangent lines are a little bit different. By definition, the tangent line is a line that touches a circle in exactly only one point. So we see an example of this here. We have line AB and it touches it only in point B. Although it does look like it touches the circle in other spots, it actually doesn't by definition. It only touches it in exactly one point. We have the point of tangency, and that is going to be the point at which the line touches the circle, and that becomes pretty important. One of the theorems we're going to use quite a bit is the theorem in the books, section 1111. If a line is tangent to a circle, so over here, if a line is tangent to the circle, then the radius and that point of tangency are going to be perpendicular. So from that point of tangency to the radius will form a 90-degree angle. We're going to use that to find angles of triangles and such, and we'll see how that plays a role in the problems that we have. All right, in this example here, this tells us that ED is tangent to circle O. That's important because that theorem we previously had, that tells us that this line and this line here are going to form a right angle. So this right here is in fact 90 degrees. So that is important. They also give us that this angle here is 38 degrees. So if we have two angles of this triangle, we know that the third angle has to be 52 degrees because both of these would add up to 90, and what's missing is going to be 52 degrees. So we have, that would be how we would solve this type of problem. And again, this is one example where we're finding angle measures in a triangle using that previous theorem. All right, this one, these problems can be kind of hard for students. So what they have is a pulley, and it's really just two wheels that allow leverage of the wheels to help. And what they have here is, if this were the tangent line to these circles, so this line right here is tangent to both of these circles, then these are going to be perpendicular to the radius, which is what they're showing here. They want you to figure out the distance between the centers of the pulleys. And so to do that, what we're going to first do is create a rectangle. Right? We're going to create a rectangle, so we're going to draw this line here, and what this makes is this part will be 8 inches long because this side is 8 inches long. This is 35 inches, so this part here is going to be 35 inches. And so by doing that, we are now able to create a right triangle and figure out the missing distance using Pythagorean theorem. So if this is 8 and the whole thing is 14, that makes this little piece here 6 units long. And so that would be the steps on how we set up most of these types of problems. So over here we have 6 squared plus 35 squared, and when we go through our square and square root, we get this distance to be approximately 35.5 inches long as your solution. So again, we use these steps here to create a right triangle to do Pythagorean theorem. All right, here's a different one. This time we want to prove if it's tangent by using Pythagorean theorem. So they give us a line, which we don't know if it's quite a perpendicular radius or not. So this is your radius. Here is a line which they're trying to figure out, is it tangent? And so what we're going to do, if this works out where 7 squared plus 24 squared equals 25 squared, then we know that this is tangent because then these two would be considered a right angle. This would be a right angle with these two lines. And so again, we're going to use Pythagorean theorem. And if it works, then it's tangent. If it doesn't work, it's not. And so what we find is 7 squared plus 24 squared is 625. And over here, 25 squared is 625. So since the left side equals the right side, then we know that this is in fact a tangent line. All right, this will come up. This is a vocabulary identification. This is a triangle circumscribed about the circle. So circumscribed means outside. So we have a circle and then we have a triangle outside of it. And that triangle has 3 points of contact with the circle in there. This is one that we constructed earlier in the year. All right, we have a new theorem here, and it says if you have two segments tangent to a circle from a point outside the circle, then they're congruent. The segments are congruent. So this segment AB is congruent to segment BC. We also know that if these are tangent, then what kinds of angles are formed here? These are going to be 90-degree angles. We also know that in this particular shape, we have 1, 2, 3, 4 sides, and a four-sided shape is going to add up to 360 degrees, which tells us that if we need to find this angle and this angle, these two angles here have to add up to 180 degrees, because these two angles right here are 90 and 90, which adds up to 180, leaving us with 180 degrees. So again, this angle and this angle are going to add up to 180 degrees. All right, here's an example here. They tell us segment QS is equal to 10 units, and segment QT is tangent, right? So segment QS is 10, segment QT and QS are tangent. So what that means is that these things are perpendicular, right? And they want you to find the measure of Q and T. Well, we just talked about this a minute ago in the theorem, that if you have two tangent lines that meet at an outside point, then these two segments are going to be congruent. So by definition, by theorem, 11.3, two segments tangent to a circle from a point outside the circle are tangent is the reason why that these two things are going to be 10 units long. And also why they're perpendicular. So if they're tangent and you have a radius, a tangent line to a radius is going to be perpendicular. So we're going to add in that second theorem. All right, next example here, they tell us circle O is inscribed. And so what we're going to do, if this is 15, what this is saying is that this distance right there is 15, which means that this distance right here has to be 15 as well. They give us this distance here is 8, so this distance right here has to also be 8. And if this is 17, then this has to be 17 as well. So really what you're doing is kind of mirroring these all the way around. So there's going to be 3 separate values for lengths in this type of problem with inscribed polygons. And so if we add that all up, we get a perimeter of 80. And these are the types of questions that you're going to get for tangent in the sections that we have.